everyone. I hope you're doing well. Let's see, I'm supposed to hit the react button. I'm sure there's a react button. There we go. I found the react button. Haha. There we go. How is everyone doing today? I hope you're doing well. Uh, so I was excited to see that Simon did this puzzle, and I look forward to seeing his solve. I will say what I usually do. I usually don't watch the solve at all, but I usually go to the very end to see what he says, because usually from what he says in the last 60 seconds of the video, I can tell whether Simon has sort of followed what I intended or not. It's fine either way, of course, but I like to know which thing to expect. I can tell you this time that Simon ended up rather far off the way that I at least sort of envisioned this being done. So I don't know exactly what he does, but it's gonna be an adventure, because the thing that I consider like the third-ish step of the puzzle, he did not fill in until like the very end. So like when I saw that he filled in something in like the 60-second or in like the last 60 seconds, is like, well, this is going to be interesting. So we'll get to see what happens. Let's see. Do I have anything else? Oh, in Arizona. Oh, wonderful, Laura. I love Arizona. I lived in Arizona for many years, and I still miss Arizona. The weather there is just so nice. Although, of course, during the day it does get rather hot, but it was also hot here today. So what can you do? Alrighty, so I guess we can get started with this. Let's see what happens.
Hello and welcome to Tuesday's edition of Cracking the Cryptic, and it's going to be a good edition, I hope, because I've got a new puzzle to try by the great zetamath. This one is called Cycles of Time and Tide. Actually, I forgot. I meant to look that up. It sounds like a literary reference to me, but it's one I'm not familiar with.
So the title I went with as a reference to the fact that I included a palindrome in this, which is like one of the very, very old Sudoku constraints. And then I sort of noticed that sort of in my mind, there's sort of like palindromes and black kropki are like the ancient ones, and then the blue lines are like a middle timeline innovation, and then the entropic lines are more recent. So I wrote the rules in that order and chose the title as a reference to that.
But zetamath's puzzles I am very familiar with. They are always magnificent. This one has been sitting at 100% for the past 2 or 3 days. And it's been recommended to us many times, as all of his puzzles are, and I'm looking forward to trying it. I did find it on Logic Masters Germany just now, and I snipped some comments, and the comments support the recommendations we've had.
Comment here.
Exegus says, just amazing geometry and a great pleasure to solve. Fuxia says, a long chain of weird and challenging ideas. Enjoyed this a lot. Playmaker 6174, we've had one of your puzzles, Playmaker 6174, is getting heavily recommended actually in the last 2 or 3 days. A sweet opening followed by a consistent and engaging flow after that. And someone says, brilliant puzzle and a beautiful break-in, thank you. So this is, I'm sure, going to be super. We've got I think these are region sum lines, and these entropic lines are the funny coloured ones, the peach coloured ones. But salmon. They're described as salmon in the rules. Anyway, we will read all about the salmon coloured lines and the other lines as well in a moment or two's time when we attempt to solve this. But what can I tell you about before that? I will mention that last night's stream it started off ablaze.
Salmon adjacent.
Now, let's turn our attention.
There are chapters here, so we can go to the thing. Happy birthday to everyone whose birthday it is no longer.
zetamath. What has the great man got in store for us today? These are the rules. We have got normal Sudoku rules applying. So we've got to put the digits 1 to 9 once each in every row, every column. Whoa, and every 3 by 3 box. Black Kropke pairs. Digits separated by a black dot have a 2-to-1 ratio. Not all dots are necessarily given.
No. I could have actually said the rather pleasant salmon-looking lines. I think that would have been appropriate.
So,
I like the color
what that
there.
means is one of these digits is double the other. So if that was a 2, this could be a 4, because 4 is double 2, or it could be a 1, because 2 is double 1. So just make sure that one of the digits is double the other on a black dot. And the line about not all dots are necessarily given is just to cater for the fact that you could have, these could be a 2 and a 4, where this digit is double this one. There doesn't have to be a black dot between two.
It should be noted, by the way, and this will probably come up a number of times as I talk through this. I said a whole completely different version of this puzzle first that had some of the break-in stuff, but then was entirely region sum lines and Kropke. And so the break-in was the same, and a lot of the deductions were actually even the same. But it got a little mathy in a couple points and a little fiddly, even with all of the things. And I didn't really want to go. I didn't love how fiddly the end was, and I put it in testing to see if people thought the same. And a lot of people said the same thing of like, I loved to break in, but the ending was a little bit fiddly. So unlike my usual, so I'm completely unabashed about having like a single black dot somewhere in a puzzle to disambiguate it. The black dot here was here very early and is quite important. And there were originally a lot more dots of various sorts floating around the grid. As it happened, it ended up that there ended up only being 2 in the end. But people who know me might anticipate from this sort of like 2 black dots that the black dots are going to be unimportant. And only one of them is unimportant, as it will turn out to be the case. But it sort of originally was a pure region sum lines Kropke puzzle.
2 digits, 2 such digits. It's just that we know for these very specific dominoes that relationship applies. And then we've got a palindrome. The single grey line is a palindrome. Its digits read the same forwards and backwards. So if this was a 1, that would be a 1. If this was a 4, that would be a 4, and then that seems to be able to be anything. So let's make it 7. Whoa! And that would be 1 4 7 4 1. So you can see if we read it from this end, 1 4 7 4 1. If we read it from this end, 1 4 7 4 1. So it reads the same whether you read it forwards or backwards, and that is the nature of a palindrome. It's like the word madam. Now, what
it
next?
Like
region sum lines. Blue lines in the grid are region sum lines. Box borders divide each blue line into segments with the same sum. Different lines may have different sums. So let's do this one. So you can see this line, it sort of meanders through, it goes from box 2 to box 1, and then it goes into box 5. And the time it spends in box 2, we can colour those, we'll colour these, and we'll colour those. And what we're being told here is that some of these 2 purples is the same as the sum of those 5 greens, is the same as the sum of those 2 yellows. Let's do another one. Those 3 are the same as those 2 are the same as those 2. Because the box border, the line goes 2 cells, then into box 4, and then back into box 7.
Funny anecdote. When I originally put this puzzle in testing, when it was back to the pure region sum lines Kropke version, I just copy pasted the region sum lines rules out of somewhere without much thinking about it. And it turned out that I copy pasted the old region sum lines rules, which said something like the sum of the digits on the line within each box is equal or something like that, which would imply that in this box in particular, it would be saying these 4 were equal to these 4, which of course was not what I wanted to be the case. So then I had to go back and dig up someone else's region sum line borders. But apparently originally in the olden days, that was how region sum lines worked, back in the ancient prehistoric eras of like 2023 or something.
So I suppose it is worth mentioning these are separate segments, because each time the line cuts a box border, it starts a new segment. And that is They are region sum lines, but we haven't got to the salmon coloured lines, the entropic lines. The salmon coloured lines in the grid are entropic lines, each set of 3 sequential.
I did think, by the way, I didn't label the lines like I usually do in my puzzles with a bunch of kinds of lines, because I thought with 3 kinds of lines of very different hues and saturations, I thought probably these were all visually distinct, although let me know if these are close, because then I will sort of keep that in mind. But if there's only 2 kinds of line, then I typically don't label them. If there's 4 or more kinds of line, I basically always label them. I don't know that I've ever had a puzzle before that had exactly 3 kinds of line. So I wasn't 100% sure whether this should be I throw RSL in the top left corner of each of these, or if I don't. But it looked to me in this particular instance like I thought these would probably be distinct enough that it would be okay. But apologies if anyone tried this and then the lines looked too similar.
Cells along an entropic line, let's look at this one, must contain a low digit, a 1, 2, 3, a middle digit, a 4, 5, 6, and a high digit, a 7, 8, 9. Digits may repeat on a line if allowed by other rules. So within this 3-cell segment here, there must be 1 low, 1 middle, and 1 high. And we don't know the order. So it could be high, medium, low. It could be high, low, medium. Or it could be low, high, medium, etc. But the thing to realise, and I don't think this is really solving to tell you this, is that there has to be 1 of each in that 3. But there also has to be 1 of each in those 3.
Yes.
And if you think that through, you'll discover there's a relationship between those 2. And that might be important. We shall see. We shall see what the cycles of time and tide have in store for us. Do have a go.
Spoiler, it will not be important. I think the last clue added to this puzzle was that I extended this line from being a horizontal 3-cell line down. So it will not turn out to be of vital importance, I think, that this line does this.
The way to play is to click the link under the video as usual. But now, I get to play. Let's get cracking. Now. I mean, I saw something as I was doing the examples there, so I might look at that first. I mean, yeah, I can't see anything else, so I'm going to do this. Right, whenever you get a region sum line that is comparing...
In a totally shocking twist, the break-in for a zetamath puzzle is in box 1. It is really covering new territory. I did see a couple of people in the Cracking the Cryptic comments saying afterwards something like, well, I didn't expect that box would be the break-in, so I spent a while looking at some other box. But unless there is a very clear and pressing reason why to do otherwise, my break-ins are always in box 1.
A 2-digit sum with a 5-digit sum, you can do something with that. Because if we think about the minimum sum of 5 different Sudoku digits, it's going to be 15, isn't it? If we populate these cells here with 1, 2, 3, 4, and 5, that's the least we could put into them. Now 15 is relatively difficult to get to in a domino. You certainly can't include a low digit. You can't even include a 5, because if you include a 5 as one of the digits, the other digit would have to be at least 10, which is not a Sudoku digit, or even a Sudoku number. So these cells and these cells are selected from at least 6. Now, a minor point, which I will make, those 2 digits can't reappear on this line in box 1. This is
So another thing that comes up in the comments. So the intended first deduction here is that this domino can't have the same composition as this domino. And several people in the comments noted that they immediately used uniqueness to note that they could not end up being the same composition, which I never once thought of while I was setting, and probably would have upset me greatly if I had noticed. that was actually a possible deduction. So I'm kind of glad I didn't. But you can notice that the puzzle could not possibly be unique if, say, both of these were 7, 8, if you imagine, because you could swap the 7 and the 8, and there's no clue of any sort that could tell you whether it goes 7, 8, 8, 7, or 8, 7, 7, 8 between these two boxes. And so, actually, if you're willing to use the fact that this puzzle is made it through testing and hence has a single solution, then you know that this domino has to be different. Uh, and that's the sort of thing where if I were solving, I wouldn't use it as a logical step, but I might use it as a meta step of, well, I know this has to end up being different, but I just literally never thought of it. It was the first thing I drew in was this line, and I thought, I bet there's some sort of clue I could add into the grid that would tell me that these two things had to be different, and that would have ramifications. And as I mentioned when I originally set this, the thing I drew in was I actually drew in a region sum line that went down through this box. You can see my mouse cursor, yeah. That went down through box 8 and shunted 2 more region sum line pieces into this. And so the reason why the original version of the puzzle ended up a little bit fiddly is that I drew in a bunch of random region sum lines, like one here and one where this entropic line ended up being, to sort of facilitate deductions. But then later it turned out that things were a little bit messy because of the fact that then those had to resolve and there were various mathy things that could happen. So that's why eventually they left. But anyway, the uniqueness thing amused me because I never thought of it.
The reason you can't put either of these digits on this line is imagine that digit, for example, was here. And so I'll just make these different colours for a moment. So imagine the purple digit was here. The problem with that is that these 4 digits then mathematically have to add up to this digit. But the minimum sum of 4 different Sudoku digits is 10, 1 plus 2 plus 3 plus 4. And obviously this digit can't be a 10. So it's not possible to put these 2 digits on this line anywhere, which means that they are in 2 of those 3 cells. Now, if they were both there, one of them at least would be on here. Could they both be on here?
It's a very reasonable thing to think of. It's not the thing I had in mind, but it's...
It would depend. This would have to be 15 then, otherwise we would get into trouble. Because if it was 16, say, 16 only has one way of making the domino work. It would have to be 7, 9. And if this was 7, 9, that would have to be 7, 9, which would obviously cause a problem for this cell. So if these are both purple, yeah, I mean, this is an if nested in an if, isn't it? It's if those are both purple and these are both purple, is there a problem? And the answer is even then there might not be a problem because these might only add up to 15. What about if this was the same as this? So if this was 8, 9 and this was 8, 9, that doesn't work because of the palindrome.
So I will say when I set this, the second version, I knew that what I wanted to be the break-in was that these two things had to be different. And I ended up just saying, you know what, screw it. I'm just not even going to decide what clue I'm going to put here to make these. I'm just going to make a note to myself, I need to put something here. And then at some point later in the solve, I'm going to figure out what clue can I add here to do that, plus a different thing that I want to do. So this is something I try and do when I'm being really conscientious about setting, is to write in, like, not a clue, but a placeholder for a clue that says, here I want a clue that does this, because I knew there's lots of kinds of clues. Like I mentioned before, there's sort of like a region sum line that would do it. There are lots of kinds of clues that would force it. An interesting thing that you could do is you could have a length 3 entropic line here, and then they can only be the same if they're both 6, 9, is something I sort of entertained and thought about. But I wasn't quite sure. But anyway, I'll point out later when we get to the point where I actually decided and committed to this line being here as a palindrome. It turns out to be a little bit more difficult, actually, than I would have thought to come up with clues that are hard countered by these two being the same domino. Like I went through like a lot of clues. There's just nothing you could draw across these three cells that would guarantee that they weren't the same. Like you could put like an arrow through here, for example, or lots of forms of region sum line. But anyway, that was an interesting bit for me. I will say, in terms of aesthetics, I actually liked the region sum line version, where what I had originally was a region sum line through these three cells, those two, and those two. And so that sort of broke because, but it took a little bit more thinking to see that it broke. But then later, I just could not find a way to draw the region sum lines through here that worked. So that made the
Right.
end
Okay.
nicer.
So what we can say here is interesting. These two cells. Well, I think there's two things we can say. Right. Yeah. So what zetamath has done here is to try and force us to notice that these dominoes are different combinations, and actually they must therefore add up to 15, because imagine these were adding up to 17. Well, then this would be 9 8 and this would be 9 8. But the problem with that is that then I have to put at least one of these digits on this palindrome at the bottom here, because 8 and 9 are going to be in these cells. So I've got to put at least one of them on the palindrome where it will get reflected here and clash. So that doesn't work. And that logic is going to be the same if this was 9 7. So in fact, these can't add up to 17, therefore they can't add up to 16, so they must add up to 15. And even if they were it's the same point if these were the same flavour of 15 domino. Imagine they're both 7 8s. If they're both 7 8s, we've got the same problem. I've got to put a 7 or an 8 here, which means I've got to put a 7 or an 8 here, and it will clash. So one of these is 6 9 and one of these is 7 8. Now, what does that mean? I don't know yet. I imagine it means something. It means that... No, it doesn't mean that at all. What I was about to say is absolute nonsense, so I'm not saying that. I don't actually know what that means. Oh, I tell you something it means. Because these add up to 15, this is a 1, 2, 3, 4, 5 quintuple. That's forced. Agree. So actually, these digits now are, let's just get rid of all this, these are the green and the purple digits. See, and now I'm wondering whether I'm meant to differentiate between the flavours of these. Because
please don't.
Obviously that digit, well, that just can't be purple. That's got to be green.
Okay, so when I was setting this, again, I had in mind, and so just if you're wondering, like, how do you come up with this? I had this idea of, I can put in this, like, weirdy shape, whatever you want to call this, like, missile shape, thing, and clue somehow that these two things are different, and then how do I use that? And so what I saw was exactly this. Oh, you labeled them as A, B, C, D. Okay, interesting. Yeah, when I was coloring this, I colored the two flavors of 15, and then I colored 1 through 5 in their own color. As in one single color for 1 through 5. It was blue for me. But when I was setting this, I noticed, I actually know this digit is green just because of how I happen to draw the line. I didn't put any deliberate thought into how I drew this, aside from that it needed to be in 2 boxes, because the deduction with the palindrome wouldn't be very interesting if these were in the same box. And so then I knew that this was green, and so then the reason why I next drew in some sort of region sum line here was that these greens were in common, and so I knew there was going to be a green here. So the math was going to be different than if this were a quote unquote normal region sum line. So literally, basically, the next thing I did in terms of drawing in clues was I'm going to draw in a clue that covers all the Sudoku places that this digit can go in box 4.
And right. So that, yeah, so that digit's on this sort of staple shape. Yeah, one of these digits is definitely on the staple shape, which might be interesting. Let me think about that. Well, oh yeah, okay. This staple shape is actually interesting. This is like what I think would happen if somebody actually talked to me at a party. They would be like, no, he looks a bit strange. We'll just leave him in the corner. And then they would talk to me. And I would be able to talk to them about staple shapes in Sudoku. And they would discover that actually I'm very interesting. Because
I enjoy how Simon is identifying with one of the characters in the puzzle.
I'm just trying to think this through. There is some problem with this. If this has a 9 on it, say, the minimum sum of those is 15. But, yeah, this is weird. This black dot's doing some damage here. Because one side of a black dot in Sudoku can't be higher than 4. Because you can't put 5, 10 on a black dot, for example. So the biggest small digit you can put on one side of a black dot is a 4.
Biggest small digit is a great way to phrase this.
So a black dot is either going to be a 1, 2, a 2, 4, a 3, 6, or a 4, 8. So one of these digits is really quite low. And obviously we could then combine that 4 with a 9 to make a 13 segment. This is huge. This is a huge... Okay, this is a good way of thinking about it as well. Because... hang on. Hang on. Yeah, so if this was 4, 8, which is the most the low digit could be, the 4 could have a 9. So let's say that was 4, 9. 4, 9. 13. So this can't add up to more than 13. It just can't. Now, we've just learned that this digit is on here. So imagine this digit was an 8. I mean, it definitely can't be 9, but I don't think it can be 8 either. Because if it was 8, 8 is on here. 8 plus 1 plus 2 plus 3, which is the minimum, is 14, which is more than 13. A knowledge bomb for you. So this digit is 6 or 7.
And this is a pretty natural setting thing here of like the green digit being on here means this total is big, but the black dot I added because it tells me, okay, the total is small. And as it turns out, the black dot somewhat magically tells you exactly what the total is in a way that I'm guessing we're about to find out. So then you're already down
6.
to like 12 or 13 as the only possibilities.
This is absolutely beautiful.
How does he know it's 6? Okay, he's doing this differently than I did,
so
unless he's seeing something obscene.
It's classic zetamath. It's just lovely. No, it is, and it is right. It is.
I don't know that it's 6
because
for another
7.
60 seconds.
The only
if
way
I'm solving
of populating the staple, the top of the staple, in order to preserve a value of 13, which we cannot exceed for the top of the staple, is going to be 1, 2, 3, 7, and that won't work in row 4, because now.
Oh, wow.
Where are we putting 1, 2, and 3 in this row?
Well, it's really good that he's thinking about this now, because I think one of the harder steps in the puzzle is identifying that you do have to put low digits in this row. But I definitely did not intend this this to work this way. So here's here's how I thought about this. So the total's definitely 12 or 13. And what I noticed is 12 never works with the black dot. Because if the total was 12, what is the black dot going to be? Well, it can't be 4, 8, because 4 and 8 add to 12, and the way the black dot is drawn, the 12 would go crisscross. And the other option is that the dot is 3, 6. But that doesn't work because you can't put a 6 in a 12 sum, because it would be 6 plus 6. And so my resolution here was, okay, well, the total is 13, but I don't actually know what the decomposition is. But again, this comes back to the fact that when I made the puzzle originally, there was some horrible region sum line over here that did something in this box, and you had to use the fact that 3 high digits went on the region sum line over here to push this total up just enough. This may be related to my somewhat finicky comment from before, so I never looked at this. But yeah, but what Simon's seeing here is very clever. I just didn't think about it. It wasn't how I thought about this when I put this together. Right. But it actually is very much in line with my next intended observation.
We can put one of them in a 3-cell entropy string, because one of these digits only is allowed to be low. I could put another one there, but that's it. There's no way to do it. So, in fact, I think my first digit is going to be a 6 in the corner, which is double 3, so it should get 2 songs, but doesn't. But if that's a 6, this is now a 7-8 pair, so this is now a 6-9 pair.
The other problem with my original region sum line thing, by the way, was something that I often complain about, which is that you usually don't want to resolve these sorts of ambiguities really late. You had to make it 85% of the way through that version of the puzzle before you could resolve which was 7-8 and which was 6-9. And I wasn't a huge fan of that because I didn't think it wasn't incredibly satisfying when you actually did resolve them in that particular version.
And there is a 6 on here. I still think this has got more legs, actually. Because... God, I'm just going to make the same argument. I mean, I'm a creature of habit. But if I can't put 7 plus 1 plus 2 plus 3 on it, why could I put 6 plus 1 plus 2 plus 3 on it? If I did that, that won't work. For the same reason. In this row, I've now got to put the 1, 2, and the 3 somewhere. I can put one of them there, one of them there. The third one can't go in. So in fact, this is so clever. Because now, not for me, I hasten to add, but look, this has now got 6 on it.
Oh, I think you definitely
have 1, 2, 3 on it.
Cleverness.
But it mustn't add up to more than 13, so it's got to have 1, 2, 4 on it. So it does add up to 13, so this must be 4, 8. Because if this was not 4, 8 and was 3, 6, what would we partner the 3 with to get to 13? It would have to be a 10, and that won't work. So this is 4, 8. One of these is a 9. Oh, and the other one I can work out. The other one's a 5. Because it's got to add up to 13 with an 8. I love this. This is absolutely... And I think we've still got more to do, because now in row 4, I've got to put 1 and 2 in, so that's got to be a 1 or a 2. Because I can only put 1 of 1 and 2 in 3 cells of entropy.
Okay, he's still exactly so far on what I'm doing, because my next thing was entirely based around this 1, 2. Although I guess I also wrote in a 6, 7 pair down here. You can actually, at this point, if you look at it, you can write down that 6 and that these 2 digits down here are a 6, 7 pair. But this also works, because this 1, 2 here is vital.
So this has got 4 on it now, because the 4 has to go somewhere in the row. So 4 is the middly digit in these cells. And there's a 1 or a 2. And then there's got to be a 7 or an 8 as well. Which is okay, yeah. So there is a purple digit here. There's a 1 or a 2 digit, which I haven't really got a colour for. But that purple digit has to be there in box 4. And therefore, 1 purple... We always knew at least 1 purple.
Okay, he's getting the 6, 7 pair now.
I don't actually think I've increased the knowledge of the world. Well, have I? No, I have. Yeah, look. Okay, I worked out this green digit had to go on the staple, but how could that be green? Well, then I'd have to put 9 on the staple, which I clearly can't do, so 9 must be here. And this is one of each. This is a purple and a green, therefore. So this is a purple. And hang on, purple and then made it green. So these cells are a sort of floating 7-8 pair in the column. So that means there is a purple in one of those as well. I mean, this is terrible, terrible, terrible pencil marking.
I mean, you say that, but it's exactly what I had pencil marked in my original version of this. Like if I show like my setting of this was entirely about this sort of like what is happening to these 6, 7, 8, 9s. The last thing, which I'm guessing he's going to notice in a second, is that this 9 is the other digit in these two cells, and so that gets you a 6, 7, 8, 9 quadruple floating in that column.
I'm wondering whether I can. I almost want to change this, I think. Just to try and keep track of the difference between these two numbers. What we'll do is we'll change the color of this one to be
I guess we
red.
can. I guess
No, I can't really see that. Blue. Okay, so what I'm saying is that I'll make that.
I fear this step is not going to be helpful.
This is a blue-purple pair, and now I can change
not that it's at all unreasonable
blue.
for him to do it. To be clear,
this is now purple, and this is. I don't actually know if this has improved my knowledge or not. It might not have done, but it makes more sense.
So I can say what I intended next here, which is to ask the question, what can this region sum line sum to? And so the thing that I intended to be observed is you actually can't put a 1 or a 2 in these two segments. And the reason why is you can't put that 1, 2 in these two cells. But the other 1, 2 in row 4 is on this entropic line, because as Simon said, this entropic line has a 1, a 2, a 4, and a 7 or an 8. And so actually this line, in the weirdest possible way, sees a 1, 2 pair. And so the smallest you can actually make this sum to is 3 plus 5 is 8. And so we'll see if this corner mark appears, but my intended next step was there's a corner marked 3 on this line, because if you don't put the 3 in there, suddenly the smallest this can sum to is 5 plus 6, which is actually too many. If you look at it, you might think, 11 is fine, because I could do 2 plus 9, but there's already a 9 in this box. So my intended next observation is that we can corner mark a 3 in these two cells, and that corner marks a 3 into this palindrome. And that was the moment, I should say, when I was setting it, that I decided for a palindrome rather than any other thing. Because I noticed if I made this a palindrome and there's a 3 corner marked in it, the thing I noticed is that 3 sees all of these 3 cells. And so it places the 3 in this box. And so my intended sort of step to sort of finish this was that corner marked 3 sees all of these cells. And so that corner marked 3 and this 1, 2 both end up on this line. And so it resolves this entropic line. That was sort of my intended flow through this part.
It's to me now. And that's probably important.
This line sees a 1, 2 pair in a weird way. It does sound like a zeta step. It definitely is a zeta step.
And what have we got here? We've got 1, 2, 4, 6. I was going to try and do entropy on this, but this is a blue line. It's definitely not salmon coloured, so we can't do that. I know this is a 7 or an 8. Let's actually put that in. One of these is 7 or 8. One of these is 7 or 8. So what's this? 359. It's not 9. That's got to be a 3 or a 5 by Sudoku. Which could...
If Simon corner marked 9 across these cells, he would see that these cells are a naked 1, 2, 3 triple.
Matter? I am not sure. Oh, bobbins, I don't know what to do now. 4. Oh, I do know what to do. Where's 4 in column 1? There's a 4 in that little quadruple, then there's a 4 in that quadruple. So 4 can't go in any of those 6 cells. So 4 is there. That's nice. That's definitely a win for the goodies.
It's a digit. We always take digits.
Can I do that with any other digit? Is there anything else in common? No. 5, though, is in common between these, isn't it? So 5 in column 1 is in one of those 3 cells. 9. 9, yeah, 9 is in one of those 2, and 9 is there. So 9 is in one of 2 positions. Right, but purple is 7 or 8.
Thanks, Carl.
And purple...
We're right at the point where Simon has perfectly followed my path up until this point and is now veering off in a strange new direction that I get to see how he manages to solve this, because I know that he doesn't do what I did next from here. So I'm looking forward to seeing how he's disentangling this.
Is here. So this is 5 by Sudoku, because this is a 9 and a 7, whichever of 7 or 8 is purple is going in there. So these digits are 7 or 8 and 3. And that's going to be important for the following reason. Come on, brain. No, okay, so this is good. So the bottom of column 1 now is a 1, 2, 3 triple, which is rather surprising. So these digits are now 7 and 6, I'm going to claim, just by Sudoku.
And I will say, I think the 1, 2, yeah, he put this 1, 2 here and then didn't think about it. It's possible that I made it harder to see that that's what I really wanted you to look at by extending this. So originally this region sum line was just 4 cells. And that maybe makes it scream more at you when you put a clue directly on it, whereas here it kind of looks like, I don't have any idea what's going on with this ridiculous region sum line. So it might have been better telegraphed-wise, but yeah, it's true. He did not really look at this 1, 2, which was definitely the thing I had hoped would get looked at.
So this is either middly or high. So there must be a low digit on here then, because whatever this is, we haven't had low entropy on this 3-cell string. And now what do we do? This black dot can't be 4, 8 because of this. Oh, no, it's better than that. It can't have 4 on it at all. That's interesting. So that doesn't just take out 4, 8. It takes out 2, 4 as well as a possible black dot combination. So it's either a 1, 2 pair or a 3, 6 pair. It's got to be one of those.
So this was the second to last clue I added. So this black dot I don't think does much. We'll see if Simon manages to get it to do much. But at the point I was when I was setting, these 2 cells were a 3, 6 pair and I didn't know the order. And I just used the fact that, well, if this cell is sort of center marked as 3 or 6, then this black dot can't be 3, 6. So it ended up being 1, 2. And that, as it happened together with this extending this entropy line, got me to a unique grid. But I also knew you wouldn't be able to resolve this very early because until you know that like this cell is 3 or 6, or basically know things tantamount to that, you probably can't resolve this. So this black dot sort of is at least intended to be resolved near the end. We'll see if somehow Simon resolves it early. It's possible.
Which is interesting, but maybe not enough. Oh dear, I'm going to get stuck now, aren't I? I don't want to get stuck.
I don't want to get stuck.
I don't really
That's
know what
true.
to look for. This is 1, 2, 4, and 7 or 8. But I don't think I know what that one is, so I can't transpose it down there. I mean, I sort of hinted at it when we did when we ran through the rules. But whatever the entropy of this cell is, let's say this was a low digit, then that must repeat here, because if this is low, these two are middly and high, and on that three cell string you've not had a low one, so that's going to have to be low, and obviously that logic is completely consistent. If this is medium, this is medium. If this is high, this is high. This one is going to repeat there, that one is going to repeat here. This one, this sort of horseshoe or small staple one, those two are the same. Right. Okay. Sorry,
yeah, I suspect that if you bully box 2 enough, even if it's not exactly what I intended, I suspect if you pencil mark box 2 within an inch of its life, I suspect you'll be able to get somewhere.
Obvious. I didn't see this though. These can't be high entropy because 7 and 8 have gone. So they could be 9, and then the other digit would be impossible to fill. So this is either 2 digits from 1, 2, 3, or it's 2 digits from 4, 5, 6. Okay, and then whatever that is, whatever the entropy is for this domino, the third one is going to be there, because this 3-cell string must contain one of each different type of entropy. So those 5 cells are either including 1, 2, and 3, or 4, 5, and 6.
Yeah, placing the 9 in box 2 is very doable.
Now, what does that mean? I don't.
It actually does quite a bit to place the 9 in box 2.
Oh, zetamath, you naughty constructor! What have you done here? It was going really well, and now I've just come to a juddering halt. It's not this one, is it? This just looks like a series of dominoes.
Definitely is that one.
And dominoes.
It's definitely what I intended, at least.
Are quite flexible creatures. I mean, a domino in Sudoku can add up to as little as 3, which that one might be able to add up to. I mean, it couldn't be 3 because then you'd have to put 1, 2 there as well. But or as much as 17. So all we can really say about this sequence, I think, is that it's not something to like 16 or 3 or 4, and anything that only has one possible way of making its total. And this is quite a low digit. So that could be as much as 9. So the maximum is 11. And the minimum is 5. Yeah, there's loads of possibilities.
I mean, it is true that this is a very weird zeta deduction involving the region sum line and the entropic line. I think he would have seen it if he'd looked at it immediately when he saw this, but then he got distracted and looked everywhere else, and by now he probably doesn't even remember that like there's not a 3 in these cells. Which is an important thing to remember if you want to get that there's not possibly a 1 or a 2 in these cells.
Getting this, am I? No, I see. Right, sorry, I'm being slow again. Right, on the horseshoe, there has to be a high entropy digit. Well, what's that? It's got to be 9, because it can't be 7 or 8. And we know it goes there because we've just worked out we can't put high entropy here, or that would be high entropy, and we'd run out of high entropy. So there's, so I've got a bit more. 9 and 6 can be done. So 9, this is lovely. So where's 9 in column 6? It's got to be right at the bottom. Otherwise it goes on the palindrome and gets reflected into a box which has already got a 9 in it. And now if this is 9, 3 cells away, we've got to have a high digit, and that's 7 or 8, which is,
It
I don't
certainly
know the
is
colour,
7 or 8.
but in terms of whether it's pink or blue, but I do know it is pink or blue.
Difficult to say.
So, right, so now these 2 cells have the same entropy. Now, the way I'm getting to that is I know those 2 have the same entropy, and the third one of the entropy of these 2 is made up with one of those. So the other one of these is the last type of entropy, and it must be completed by those 2 being the same entropy. I feel like I'm saying entropy a lot, but that means, okay, what does that mean? That gets repeated.
We all say entropy
there,
a lot.
but that could be, that could be just about anything. It could be low entropy, it could be 1, 2, 3, I think. Or it could be medium entropy if it's 5 or 6. Hang on. It is difficult for this to be medium entropy because it can't be 4 and it can't be 6 because of the palindrome. So it would have to be 5. And this would have to be 4. And, I don't know. I mean, it looks plausible that that could be the case, actually. Okay, so this is either a 4-5 pair, or it's making a 1, 2, 3 triple in the box. Which... is this possible? I don't know. I'm not sure. Oh, I feel like I'm being devastatingly stupid. What's going on? Okay, where is 6 in box 8? That is a reasonable question. It can't go on the palindrome because it'll reflect into a box that's already got a 6 on it. So it's in one of those 2 cells, which I now know is that one actually, by Sudoku. That's good. That's good, isn't it? Because now one of those is a 6, which unfortunately could include this digit. But we now know that this is definitely low entropy, because we've got to put a low entropy here. This is medium entropy, because it's got to mimic the 6. So that's 4 or 5. I don't think that's telling me how this works. I might be wrong.
It is true.
Hang on.
If there's really low-hanging fruit while I'm streaming, it very rarely persists because someone in chat will point it out as that, you can use Sudoku to do this.
One of these is 9, so that's not 9. Sorry, there's all these opportunities to do things that I've been missing, but we're slowly but surely getting through it. Now. So that's a green digit, isn't it, I suppose? I never differentiated my greens. I probably ought to have done, actually. Let's make 9 into
we're upgrading
lime green.
from 3 colors to 4, I see.
6 dark green, so this should be lime green. Then we're probably in good shape if we do that. Right, so... Oh, this is good. This is very good. So 6 is on this region, some thingamajiggy. So what did we say? We had we haven't got a maximum...
Oh, that's really interesting. The 6 ending up here was totally unintentional. Because by the time that was sort of by the time you did what I had in mind with this, you knew this whole triple, and so it was just sort of sorting it out. But the fact that he's getting the 6, maybe that's going to get him to squint at this enough that it will resolve this This region sum line?
We can't put 9 here anymore. So this is a maximum of 8. So 10 is the
Anymore.
maximum. So this is 6. And 1, 2, 3, or 4. That feels like it's... I mean, it's a ludicrous pencil mark, but just to try and keep track of the possibilities.
I love how much having lots of
do
digits
that.
pencil marked in a cell
10
pains
is the
him.
maximum, 7 is the minimum. So this digit is at least a 5. Because we have to make this domino add up to at least 7. So this is 5, 7, or 8. It feels like we should be able to do something with that, but I can't see how to make...
Yeah, so the exact reason why I drew this line in the first place, I sort of walked through why the total has to be at least 8 before. The reason why I drew this line the way I did is I exactly wanted you to know that this was a blue-purple digit. And so I deliberately drew this line so that even way, way earlier, you could have just, if you looked at the like 1-2 pair that Simon didn't see, you could color this as the 7-8, and in the original version, you could color it as the 6-7-8-9 without even knowing whether it was a 6-9 or a 7-8 yet. But that was why I drew this, was because I specifically was trying to continue the break-in of coloring these 6, 7, 8, 9s bouncing around the grid. And so that sort of resolved a lot of that sort of 7-8 business. But Simon didn't see this, which is why I think Simon is being slow here going through this, is because Simon is like, this doesn't feel like a Zeta step. I feel like I'm missing something, is what I feel like is in sort of like the hesitation in some of what he's saying now, because he's right. He's done enough of my puzzles to know somehow he's sort of strayed a little bit from the path.
Work. Bobbins is the statement we're looking for. Right, and what about that digit then? Yeah, that digit's quite an interesting creature, because by Sudoku, that's going in one of those 3 cells. But it can't be this digit, can it? Because this digit, this specific digit, can't be 7 or 8, so it can't be that digit. It can't be 9, so that digit is that digit. Oh, I've just managed to pick the worst colour ever. I'll switch it to black. So these digits are...
I don't love colouring digits in black, if I'm honest.
We know that this is either from 1, 2, 3 entropy or 4, 5, 6 entropy. I'm actually really close to being able to say this can't be middly entropy. So it's either, in order to be middly entropy, it now has to be 5. Now, why is that possible or not? If this was 5, this would move up in value. It would be 7 or 8, which would mean it would be a shadable digit. And if this was 5, this would be 4, because we know these two have the same entropic property. And
a thing that's interesting that he's never said that I think would also get him where he's going is that this 1-2 is definitely on this entropic line. Like this, which was one of the sort of pieces of my argument, was that since you were probably tracking where all the various pieces were going, that you might notice that this 1-2 had to be on the entropic line. I feel like that would probably also sort this out for him if he looked at that. But I think he's zoomed in on the like tracking these digits and not really thinking about, oh, this is one of the low digits on this. Is there another one?
Oh, that's it. Right. Oh, that's brilliant. This is brilliant. Okay. And
Oh no,
I don't actually think this is very easy to see, to be honest.
I'm worried what he has seen.
I'm not actually certain. I might be wrong as well. Oh dear. No, I'm right. I'm right, I tell you. This is bizarre. Okay, what I'm trying to think about is whether these two digits can be low entropy. I'm going to claim no, which is actually going to mean that these are 5. Okay, because what I'm going to do is I'm just going to take 5 out of there. We worked out earlier that because these have the same entropy, these are either both low or both middly. Now, if these were both low, what I'm going to claim now is that this digit here, let's just make that a red digit for a moment. These two cells.
Oh yeah, I guess so. I guess what I said before actually would have done it, because if this is low, I have to then so yeah, Simon could have seen it this way. If this is low, then you have to put both of these two digits on the entropic line, but you know one of them goes there, so that just breaks right away. So Simon actually could have sort of fallen back onto the path if Simon had seen it that way. I don't think that's what he's about to say. Maybe it is, but
See that one, which is a low digit, and they see that one, which is a low digit. So those two are the same. If these are both low, this must also be the red digit, mustn't it? It must be, because these two see that one and they see that one. But if these are both red, where do we put red in column 4? We've got to put it here. But it can't be.
I guess this is basically the same point.
Because we know it's this digit which sees red. So it just falls apart. I mean, it's a really odd way of thinking about it. That's just my fault. That's just the way my brain works. But that means these.
I'm impressed he saw it that way.
It means these are middly, which means they're 4 and 5. And that, I thought we could do the order of those. Well, yeah, I mean, we can once we do the transposition. Oh, yes, it was coming from here. Right, so I was wondering, because I knew I could do it from there, but I thought I managed to do it from somewhere else. So this is 5, this is 5, this is 5. This is 4.
What do we think the odds are that Simon deliberately highlights these cells repeatedly and looks at these cells and then doesn't fill in that this is a 7 for like comment farming? Because I feel like I would do that, but I think I'm also trollier than Simon. But I feel like it must just drive like a just specific kind of viewer just absolutely nuts to see him do this repeatedly. And I wonder if it's just to inspire algorithm comments.
So these are not 4.
I definitely would do that.
And
I so would.
These are from 1, 2, 3. So we're getting an awful lot of low digitage here, aren't we now? This is not 4 by Sudoku using this digit. And
with me, it's usually less comment farming and more like outright trolling, but I definitely will do it if like a million people are telling me to like fill in the one digit, then at some point it's like, well, what if I just don't
anymore? Oh, that might be important. Oh yeah, that is important. Whoa, what's going on now? So now these digits add up to at least 8. So one of these is 6, so we can't include 1 with it. It wouldn't add up to enough, would it? Don't think it would. So this is 6. It could still add up to 10. If it was 8, 2, 6, 4, it would work, which seems to be a plausible thing. Right. So do we know what this one is? That one by Sudoku is one of those 3 digits. I'd really be quite keen on knowing what this digit is as well. This has probably all been available for ages. These are 7, 8, 9. How do we do this?
Yeah, this is definitely, it's quite rare that Simon does one of my puzzles in not basically the exact order I did it. So it's quite a thing to watch when it happens, because it usually involves a lot of interesting deductions that I wouldn't see. But most of the time it's sort of like oh, he's basically reading my solution path document. Uh it's funny, when I submitted stuff to CTC, I used to always send in a solution path document, and at some point Simon was doing things that were so similar to my solution path document. I was like, if I stop sending it in, will it change? But he wasn't any less similar to my solution path document when I stopped sending in solution path documents, for whatever that's worth. So I think he's just a mind reader for the most part. Uh, I feel the odds are quite good that Simon is going to resolve this digit in a way that has nothing to do with those two. That is David's question. I think there's a decent odds of that.
I do not know. Oh, it was going quite well for a moment, and now I've got stuck again. This digit is one of those two. It's one of those three by Sudoku. That digit is blue or purple. Do we know whether it's the same as this one? I'm unsure. I'm not sure about that. Oh, hang on, I've got a 4-8 there, so that is a 7. So that's 7, that's 8. So could this be 7? Because otherwise this one has to be. The only way you can put a high digit on here now is if it's an 8, which bizarrely enough looks possible actually, which is incredibly annoying. Right, 5 is in one of those cells. 9, oh, hang on. Yeah, 9 is in one of these three, and it's definitely not on the black dot. You can't put 9 on a black dot because the digit opposite it would be 4.5 or 18, neither of which is valid. So can that be 9? Then this would have to be 7 or 8. Maybe it can. Yeah, that might be possible.
I have messed up 6 times 7 kind of stuff in my lectures plenty of the time.
And this
Hey,
digit
Colin, by
is
the way.
either a 1, 2, 3 or an 8. Goodness me, I don't know what to do. 4. 4 is quite restricted actually. Yeah, 4 in box 2 is in one of those two cells. So 4 is on the entropy. Oh, that's beautiful. That's done it right. So 4 up here and 4 here, and the 4-8 pair here forces 4 onto the entropy line. 4 is from middle entropy, so this can't be 6. That's got to be 7. So 7 and 6 go in. So this is not 7 anymore. This is not 7 anymore. Oh, this must do something, please. It means I can't put 8 into those cells now. So 8 in box 8 is in one of 2 places. Oh, no, it's not. It's in one place, because that can't be 8 because of the 4-8 pair. So 8 goes here. 8 goes here by palindrome. Oh, and 8 goes up there, which we sort of shouldn't be surprised by. And this needs a low digit on it. So these are from 1, 2, 3, and 4. Oh, in fact, that's just obvious. This is a 1, 2, or a 3, because I haven't put 1, 2, 3, and 4 into this box. So this is a 1, 2, or 3. And this is a 7 now. Okay, by Sudoku. So this isn't 7. This is 1, 2, or 3. And for our next trick, we will say that I don't know what we're going to say now. Oh, this can't add up to 10 anymore, look, because this has lost its ability. Oh, that's been ever since this couldn't be 8, I think. So this is a
Which just sounds
maximum
good.
of 9.
It's not been very long.
So we can't put 4 on here with the 6. That's going to make that too big. So 4 moves up in box 2. And this is either 8 or 9, which is exactly what we've got beneath it. So actually that makes total sense. But I must be able to get the parity of this one by the secret. Because they must add up to an even number. Even, even, even.
I feel like what Simon's going to get here is the fact that there's a 2 in one of these, which I guess is fair. I would say there's a 6 and a 7, so this digit is one less than this 1 2 is less than this 2 3, and so it's like a white kropke between a 1 2 and a 2 3, so it has to have a 2 on it. So this isn't 2. I think is what Simon's going to end up at this.
I mean, that's completely bonkers what I've just done there. But I sort of used the secret. The secret of Sudoku is something I share with only my very favourite people. And of course, if you're watching this video, you're definitely one of my favourite people, so I'm going to share it with you. A complete column of a Sudoku, by the rules of Sudoku, contains the digits 1 to 9 once each. And if you sum those digits, you get 45, which is odd. Now, 2x, these segments each sum to x. I don't know what x is, but I know those 4 cells therefore sum to 2x, which is even. 4 is even, 8 is even, and 5 plus 9 is also even, it's 14. So these 8 digits sum to an even number, so this has to be odd. And is that useful? No. Probably not. Hang on. It would have been more useful if it was the other way and it had to be 2. That would have been properly useful. This can't be 8 anymore.
True.
Oh goodness, I don't know what to do then. 1 in this box is on the thingy, so this is not a 1. So 1 is in one of those cells. That is not a 1. We've sort of got a triple going on in box 5. I'm trying to see how to use that. It's quite interesting the way zetamath has set this up. There's really not much going on in these final 4 columns, or 3 columns, sorry. We've got a couple of stumps of region sum lines. And I feel this will only be useful once I know what the entropy of that one is. Or maybe maybe the point is I could know the entropy of this. Is that possible? Oh, yeah, that's an interesting idea. Yeah, the maximum sum of this is 9. So look at this domino. Is it possible it doesn't contain a 1, 2 or a 3? No, because if it didn't have 1, 2 or 3 on it, it doesn't have 4 on it either, so it would be at least 5 plus 6, which is way more than whatever this is.
Okay,
9
now we're back to saying
so
words.
There is a low digit on here, and look at the row now. Low, low, there's another low there, so that can't be a low digit. That would be 4 1 2s and 3s in the row, so that's a 6. So 6 is now in one of these cells. It looks like this is trying to be 3 6, doesn't it? It's doing its very best.
I did ultimately decide on this black dot here because of the fact that I had the 6's corner marked across both of these, and sort of like, oh, this really wants to be 3 6.
That digit is in one of those 2 positions. One of these is low. So the only option for this cell is 5, 8 or 9. It's either middly, in which case it's 5, and then this would have to be 4. Or it's high, which would make this 7 or 8. So this is 4, 7 or 8. Okay. I don't know what to do with that. Is it? Okay, there must be a 7 on here, which by Sudoku actually that's not an intelligent thing I've just said. And then there's going to be a low digit. Oh, there's got to be a 4. Because this string of thingies, this string of salmon, has to contain a middly digit, and it hasn't got 6 on it, and it doesn't have 5 on it. So it must have a 4 on it, and therefore this is not a 4. So this is a 4. So this is a 5. Okay, so maybe we can...
Yeah, I drew this salmon line, the little one. I drew that in after I placed this 4 from that deduction. Because ultimately in this puzzle, I was always going to have to disentangle column 2 and column 3, and no matter how I did it, I was afraid it was going to be horrifyingly inelegant. Although I will say someone in testing said their favorite clue in the puzzle was this little line, so I was fairly happy with the way I ended up doing it. It didn't feel too absurd to me or too out of line to do something like that. But basically, the way the structure of the whole break-in was set up, these two columns had to be identical, and so you needed something that reached in or touched them or something in order to actually sort out which direction they went. I was fairly fortunate, at least, that the way the sums and everything worked up, it was possible to do it with one clue, and there weren't like multiple deadly patterns floating around or anything like that.
Do something with this. I shouldn't have said that. I can't. There's an 8 in one of these. And the low digit on this entropic string, we know very little about. Good grief. Okay, so that... I'm not actually sure this does do it. Okay. What is going on here?
So these region, or sorry, not the region lines, the entropic lines for most of the time I was setting were just 3 cells straight across, and I knew I would extend them at some point when I was sort of wrapping it up. But the reason why Simon keeps looking at them and deciding they don't do anything is because at the point that I was setting where he were at the point in setting where I was similar to where he is, they were just 3 long, so they definitionally didn't do anything because the cell wasn't there. So if you're curious, like, why is it he keeps looking at these and there's nothing happening, it's because when I set this, I actually set it. And the nice thing about entropic lines is you can always extend them if you're setting, and it will not change any of the earlier logic. And so you can sort of start with a 2-cell entropic line, and just each time you want it, just grow it by 1 at a time or something like that. And so that's often what I do with entropic lines, or whispers both have this property. I periodically contemplated extending this palindrome, but every time I contemplated it, I had nightmares about what it might do to the other parts of the solve and did not really want to mess with it, so I didn't.
Let me just think about this for a moment. Okay. No. Oh, I thought I'd come up with a really good idea there. 2, 3. I have. Oh yeah, that's lovely. That is lovely. Right. This can't be 2. Because I couldn't put that digit in this row, I think. This might be wrong, but I think that's true. If this is 2... I think this is 3 and this is 1, which means this is 1. So we just have to think about the relationship between these 2 digits. If this is 2, this is 1. But now, where do I put 2 in row 5? And the answer is nowhere, because you might say, oh, I could put it on here. I definitely can't put it on there.
Oh, he got here
because
to this
if I put
point
it on
now.
Here, what digit does it accompany to add up to 9, as it would be? It would be a 7, wouldn't it? So this would be a 2, 7, and that would be a 7, and that would break the world. So this is 1, this is 3, this is 2, this is 1, this is a 2, 4 pair, so this isn't 2, so this isn't 1, this isn't 3, so this isn't 6. Okay, so now we're adding up to 8 on this region sum line, so we're not having 3 up here. This is a 2, 6 pair. So this is a 1, 3 pair. So this is a 2. So this is a 1, 3 pair. This is not a 2 in the corner. It could be a 3 in the corner.
It could be.
And we're adding up to 8 in these two dominoes. So this domino is 3, 5. That's all it can be now. Can't be 1, 7, can't be 2, 6. So this is not 5. We've got an 8. Oh, this is good, because we've now got an 8, 9 pair here. But more importantly, on the entropy, on the salmon line, the salmon moose. How did we all die at the same time? The salmon moose. By far the best Monty Python film. I know you all agree.
Which Monty Python film is that?
I've got distracted. So what's this then? Well, this can't possibly.
The Meaning of Life?
It can't be 3, 5. There's far too many 3s and 5s
but I've only seen it like twice.
If this is 3, 5. Yeah, if this is 3, 5, this is 1, 2, and that can be nothing. So this is 1, 7. So this is 3, this is 1. This is not 1 or 3, so this is 2 or 5. So this is 1 or 3. This is 6 by Sudoku. This is 2.
Now it's all going into place.
This is 8 now. Right, so 9 and 7 go in. So 8 is the blue deal. It's so bad. My pencil marking is dreadful. But anyway, and it hasn't really worked. But but the puzzle's still getting solved gradually. This is a 3, 8 pair now. So in this row, we've not put 2 and 4 in. Let's pencil mark that. That is 1 low and 1 middly, so that makes sense. We haven't put... I was going to say 5. My scanning's awful. That's a 4. So that's a 4 and that's a 2. So this is a 4, apparently, on this funny old line. So that can't be a 6. It would be 2 entropic digits from the same set together. That can't be a 6, apparently. Why do I think that can't be a 6? Oh, because that can't be a 3. Yeah, so this is a 6. Which means that isn't a 6. All the even digits are now placed in column 9, so this must be an 8. This is an 8 by Sudoku.
It's really funny when you end up with randomly all the evens or something somewhere.
Yeah, we can do that. We just talked about 6. So 6 goes there. Now this is 1, 2.
Yeah, and in my head, this was just a 3-6 pair, and the fact that it was a 3-6 pair told you what this black dot was. But yeah, the way he had done it, he had carefully kept track, so he actually got this 6, so he didn't get the cute, oh, I have a black dot looking at a center marked 3-6 cell that I always enjoy.
So this is 1, 7. So that's 7. So this is now 9 to be high. This has got to be a low digit, which must be 3. So that's 3, 5. This is 1, I think. Okay. And that's 3 in the corner. That's 3 in the spotlight, losing its religion. Oh, it's great. It's absolutely lovely. 1, 3, 3, 8. 8, 4, 4, 2, 2, 5, 5, 9. That's a
I'm sure at this point he's
activity
just happy
on that
he
side
doesn't
of the
think he's
grid.
going to have to record
And now
another
we need
puzzle after
6
this one.
here. This has got to be 9. So if we haven't made a ricket, we need 2 and 5 into that bot. It looks good. The Sudoku looks right. I mean, the colouring is absolutely all over the Swanee. But is it correct? Yes, it is correct.
It definitely looks like my puzzles look when I set them. It tends to be this sort of morass of whatever I'm keeping track of at the time, and then usually it turns out that, like, by the time someone actually solves it, they don't have to do any of this.
Solved and found the answer to the cycles of time and tide by the great zetamath. That was seriously brilliant. I absolutely loved this staple and this weird black dot limiting it, which was very, very strange when I started to think about it. And then I liked this entropic line forcing the nature of this staple. That was cute. Then what did I like next? I loved the way I loved the fact that I could work out what this line was by thinking about this row. Oh yeah, there was something I did. Yeah, the black digits, that was another lovely step. That you couldn't, because I worked out quite quickly that these had to be the same entropy. And then seeing that they would see that digit, and was it that digit? And that would plonk the same digit there that the palindrome was plonking there. That was gorgeous as well. It's a brilliant puzzle. It's brilliant. You're dealing with a man with a phenomenal IQ when you do battle with zetamath, but he's kind enough to normally let you win. which is the sign of a gentleman as well.
Why,
So
thank you,
let me know
Simon.
in the comments how you got on with the puzzle. I enjoy the comments, especially when they're kind, and we'll be back later with another edition of Cracking the Cryptic.
Well, that was quite interesting seeing the things that Simon did and didn't notice. I do think that probably what threw Simon off is probably the fact that I extended this region sum line because it made it a little less loud that the 1-2 here was really what I wanted you to think about. And like the sum of this line is forced even just by the 3-cell version once you carefully examine how everything else sort of fills in. Uh so like it's always a question of like, okay, exactly, if I make this clue bigger, usually that makes the telegraphing better, but in this case I think it looked so unappealing that it was all of these lines together, that it made him look for other things. And he indeed found other things, and a lot of them ended up eventually being tied back to these. I know Simon has watched some of the reactions. I doubt very much Simon watches all of the reactions, but I know he's watched at least one or two in the past. But hi, Simon, if you're watching. But the grid is either all colored or no color. I agree, David. That is very much my strategy, as you know, as to either I'm coloring everything and I'm committed, or I'm giving up early and just wiping all the color. Yeah. This is like right on the edge between the two. Like for this, I think it turns out that like if you delete the coloring after a little bit, then it works out okay. But yeah, you could even shift over and start coloring for entropy, which honestly was my hesitation. Uh, like what I really wanted when I don't know if I specifically said why I chose entropic lines, is that when I was originally setting this, what I needed for my break-in was I needed this region sum line, the staple, and the black dot. I needed a thing that told me these two things were different, which eventually became the palindrome, but I didn't decide that until much later. And I needed something over here that told me that I needed a 6, 7, 8, 9 in here, because that was going to give me that high digit was over here, which gave me this 6, 7 pair down here, which excited me. And so I was like, what kind of clue could I draw here that would force there to be a high digit in here? And entropic lines seemed like a really natural thing to force there to be a high digit in these 3 cells, especially given I also wanted to use the fact that I wanted to place the 1-2 pair in this row, placing a 1 or a 2 there. And I saw the entropic line would sort of do double duty and do both of those things. And so I was quite happy to use entropic lines there in sort of the version 2 of the puzzle. Again, this was originally a region sum line that had sort of like 2 tentacles reaching into box 3 in a complicated way that you sort of eventually had to figure out how you were going to split up all of the high digits among things, but that sort of was why I ended up going with entropic lines. But I was a little afraid to use entropic lines in a puzzle that encouraged you to color at the beginning, but that you were coloring something other than entropy. And the 6, 7, 8, 9s in particular don't play very nicely with entropy, since 3 of them are high and 1 of them is medium. But it worked out. I was happy with how it ended up, although I think this is one of my puzzles where it turns out that a lot of people solved it in not the way that I intended, which maybe I should think about and maybe consider this to be maybe I shouldn't consider this too successful if a bunch of people did this in ways that didn't use the sort of observation about the 1-2 pair in this box. But anyway, thank you for joining me in this journey through Simon's Solve. Thank you to Simon for solving it, as always, and for the kind words, of course. Yeah, I mean, it wasn't so much that there was a tentacle monster line that was a problem. It was that the math of the tentacle monster line required a fair amount. I once looked at a puzzle and decided not to do it because I didn't want to think about how I would color something with both entropic and modular lines. You just color every cell in 2 colors based on each of the colors, and then it uniquely determines the digit. I've done a couple of those. There's like a niche genre of puzzle that is where the puzzle is almost like how do you color this to communicate the information that you have that can be fun now and then. Uh, like sometimes you want to color like both odd, even, and sums to 10 or something like that, and end up with that sort of stack. Uh, all right. Well, thank you for joining me, everyone. Uh, Thank you for the support. Maybe use colors for one and letters for the others. Oh, there is a horrifyingly cursed idea. I love it. Uh, I mean, technically, you don't have to use colors for one and letters for the other. Maybe you use two letters for the modularity and one letter for one of the specific high mid lowities, and then you use the three colors for the others, and just mix and match across all of these. Uh, oh yeah, there's a. Uh, I think coloring is something I learned a lot about from Mark when I watched Mark videos at the beginning, because Mark does a lot of those puzzles. Uh, yeah, the uh, I've enjoyed. There've been a number of puzzles where you had to like decide what the groups were of each entropy or whatever, but colors and circles is fun. Yeah, you've got to catch up things. Yeah, the I particularly like my condiments. Uh, but yeah, alrighty. Well, I'll be streaming again on Sunday, so you can look forward to me solving some puzzles around then. Maybe we'll tackle the next puzzle in my catalog as well, which is Kodama, I believe. Uh, but I'll head off for now. But thanks for watching. Bye for now.